We've taken care of numbers, booleans, and plus expressions, and times expressions are straightforward. We can keep looking at different kinds of expressions, and so let's look at if next. What should be the type of this expression? Well, the first thing is that if wants a boolean here, so it's good that when we get the type for true, it has type bool. And when we get the type for 1 and 2, each of those have type number. So intuitively what that means is no matter which branch we take, we're going to have an expression that has type number, which in our intuition corresponds to something that returns a specific number. But that just justify saying that the entire if expression itself has type num. On the other hand, if we had if plus 1, 2 with 1 and 2 in the branches, the plus 1, 2 here does not have type boolean, and so if would not be happy when it gets a non-boolean answer to dispatch on. Even though that 1 and 2 have type num and those are consistent, we're going to rule this if out. We're going to say it has no type because we don't have a boolean typed expression for the test. Another problem would be is we do have a boolean typed expression for the test, but the branches are different. The then branch has a number type, the else branch has a boolean type. And so we now don't have a consistent type for the two branches, and if we don't know which one is going to be evaluated conceptually, we don't know whether we're going to get a number or a boolean back. So again, we're going to say this has no type. But we're not going to make this decision by running the program. We're going to make this decision based on these immediate type classifications. Here's the general rule. It says if you've got an if expression with some test, some then, and some else, get the type of the test and make sure it's bool. Get the type of the then, and well, it's something. We don't have to say exactly what it is, but we'll say it's called type sub 0. And get the type for the other expression, and let's say that that also has to be type sub 0. And the fact that we use the same name here, type sub 0, implicitly means that these must be the same type. That's how this notation works. And as long as those two are the same type, then we can produce that very same type as the overall type of the if expression. So if we want to say what is the type of if true 1, 2, then we can match it up with this rule because true has type bool, 1 has type num, 2 has type num. These two nums are the same, and so we can use that same thing down here at the bottom. On the other hand, if we try to do this with if plus 1, 2, this line doesn't match up with that pattern because we're expecting bool here and we got num. So we can't write any type 0 down here. We just have to say this expression has no type. And similarly, if we have if false 1 false, the false here does have type bool, so that matches up this part of the rule, but we get num back and bool back from the recursive calls on the then and else branches, and those are not the same type 0, and so once again we have to say that expression has no type.